5, Section 3, we will give a short introduction to polynomials. Before we can define polynomial, let's go through a few definitions that you have seen before. First, a term is a number or a product of a number and variables raised to a power. A coefficient is a numerical factor of a term. A constant is a term which is only a number. And a polynomial in X is a finite sum. Finite means it comes to an end at some point in time. A finite sum of terms of the form ax to the n, where a is a real number and n is a whole number. That's a wordy definition that you probably won't use. You have seen polynomials before, but now we're going to give them a name. So here's one example of a polynomial, 7x to the 5th plus x squared y squared minus 4xy plus 7. There are 4 terms, and you might notice that every term is separated by plus signs and minus signs. So we have 4 terms, 7x to the 5th, x squared y squared, negative 4xy, and 7. The coefficient of each term is the numerical factor we're multiplying by. So the coefficient of 7x to the 5th is 7. The coefficient of x squared y squared, we don't see a number, so it's understood to be 1. The coefficient of negative 4xy is negative 4. And the coefficient of 7, anytime we have a constant, it is its own coefficient. And in this case, 7 is called a constant term. We can also distinguish between 3 different types of polynomials. A monomial is a polynomial with exactly 1 term. You can look at the prefix mono. If you're listening to a stereo system and you're listening in mono, all of the sound is coming out one speaker. Binomial is a polynomial with exactly 2 terms. The prefix bi, like a bicycle, you have 2 wheels. A polynomial that is a binomial has 2 terms. And a trinomial, tri, like a triangle has 3 sides or a tricycle has 3 wheels, is a polynomial with exactly 3 terms. When speaking about polynomials, it's important to know its degree. We say the degree of a term in one variable is the exponent on the variable. The degree of a constant, remember a constant is just a number, so we say the degree of a constant is 0. And the degree of a polynomial is the greatest degree, the largest degree of any term of the polynomial. For example, 9x cubed minus 4x squared plus 7, the largest exponent is 3, so the degree is 3. And in any situation where a term has more than one variable, the degree of that term is the sum of the exponents on that variable. For example, if we had 5a to the 4th b cubed c, we would add all the exponents, which would be 4 plus 3 plus 1, which is 8. So let's go through the next 3 examples and find the degree of each polynomial, and also label them as monomial, binomial, trinomial, or none of these. When we start with negative 3x squared plus 6x plus 5, to find the degree, we look for the largest exponent, which in this case is 2. So the degree equals 2. To determine if this is a monomial, binomial, or trinomial, we simply count the terms. Remember, every term is separated by plus and minus signs, so we have 1, 2, 3 terms, making this a trinomial. In the next example, we have 12x minus 5. Let's start by trying to find the degree again. The degree will be the largest exponent. Here we only have one variable present, x, and remember, anytime we have a variable without an exponent showing, that exponent is 1. So the degree in this polynomial is 1. To determine if this is a monomial, binomial, or trinomial, we count the terms. Terms are separated by the minus sign, so we have 1, 2 terms. This is a binomial. And last, we have 8x plus 4x cubed plus 3x squared minus 2. To find the degree, we find the largest exponent, which in this case is 3. The largest exponent does not have to be written first. A lot of times we will write it that way, but as you're going through your problems, don't assume it's always the first exponent. So the largest exponent is 3, meaning our degree is 3. And as we count terms, we have 1, 2, 3, 4. We don't have a nice word for that, like monomial, binomial, or trinomial, so we just say it is none of these. We can also evaluate polynomials for particular values, and that involves replacing the value for the variables involved. For example, if we want to find the value of 2x cubed minus 3x plus 4, when x equals negative 2, we will replace x with the negative 2. So we now have the expression 2 times negative 2 cubed minus 3 times negative 2 plus 4. We could start by evaluating the exponents. Remember your order of operations. Negative 2 cubed is negative 8. Everything else would stay the same for the time being. We now have two instances of multiplication. We'll start with the one that appears to the left. 2 times negative 8 is negative 16. We now go to the next instance of multiplication, which is negative 3 times negative 2. It becomes positive 6. And then one at a time or all together, we can add negative 16 plus 6 plus 4 will result in negative 6. Combined like terms before, but let's discuss like terms using the definition of polynomials. Like terms are terms that contain exactly the same variables raised to exactly the same powers. And only like terms can be combined through addition and subtraction. So let's simplify each polynomial by combining like terms. In the first example, negative 4x plus 9x. Each term has the same variable. Each variable has the same exponent. So we can combine the coefficients. Negative 4 plus 9 is positive 5, and the variable stays the same. We don't rewrite that as x squared or anything else crazy. We keep the variable exactly the same. In the next example, 10x squared plus 8 plus 3x squared minus 9. We have a term with an x squared, another term with an x squared. So those are like terms. We add those coefficients. 10 plus 3 is 13, and the variable stays the same. We also have two constant terms, 8 and negative 9. Now, because neither of these numbers has a variable, these are like terms, and 8 minus 9 is negative 1. Going to the last example, we have 6x squared plus 8x minus 9x minus 4. As we go through looking for terms with an x squared, we only have one. And so 6x squared has no like terms. We can just rewrite it in the answer. We have two terms with a variable of x to the first power. So we can combine those coefficients. 8 minus 9 is negative 1. So this will become negative x. And then at the end, we have a minus 4. There are no other constants, so we just carry it along in the answer as well. Example. Here we have many more terms. Let's combine like terms in order to simplify. So starting at the left, we have a term with the variable x squared y. And remember, since there's no coefficient written, that coefficient is 1. As we go through the different terms, we find 10x squared y has the same exact variable, the same exact exponents. So we can combine those coefficients together. 1 and 10 make 11, and the variable will not change at all. It'll stay x squared y. Now what I like to do when I have lots of terms is cross through those terms once I'm finished combining them, so I don't try to use them again in a different addition or subtraction. We now go to the next term. We have xy, and if we keep going throughout the problem, we see the last term also has an xy. Now remember, each of these will have a coefficient of 1. And because the variables and exponents match, we can add those coefficients. 1 and 1 make 2, so this will be plus 2xy. The variable does not change. Our next term, well, first, before we go to the next term, let's cross out these xy's because we've already used them. The next term that is not crossed out is a minus y, or really minus 1y. And later in the problem, we see we also have a minus 2y. Those variables match, so we can combine the coefficients. Negative 1, negative 2 will add to make negative 3, and we keep the variable the same. Here's another example where we will go through the same process. Starting with the first term, 5 over 28 x to the 4th. We look throughout the problem to see if there's any other term with an x to the 4th, and there is not. So because it has no like terms, we just write it down once. I'm going to cross through that term. Now at this point, I'm going to go through the problem a little bit differently and just look for the next largest exponent. The next largest exponent is x cubed. We see that this is the only term with an x cubed, so we can rewrite or just bring down 6x cubed. And I will cross through that term as well. As we continue to look throughout the problem, we have no terms with an x squared, so we go to x, and we have two terms with an x. We have a negative 5 over 14x, negative 13 over 28x. And for the time being, I'm just going to rewrite this in parentheses, negative 5 over 14x minus 13 over 28x, because remember, we can't add those together yet. We do not have a common denominator. But since we've rewritten those from the original, we can cross through each of those terms. And then after x, we look for constants. We have a 1 over 14, negative 1 over 7. So we'll put plus 1 over 14 minus 1 over 7. And we cannot combine these yet either because we need a common denominator. So off to the side, let's find what our common denominator should be for each of these like terms in parentheses. We have negative 5 over 14 minus 13 over 28. The least common denominator between these two numbers will be 28. So we need to multiply the first fraction by 2 over 2, which would give us negative 10 over 28 minus 13 over 28. When we combine those, that will become negative 23 over 28. So as we go back to the problem, we rewrite 5 over 28x to the 4th plus 6x cubed minus 23 over 28x. Let's do the same thing with this last set of parentheses. 1 over 14 minus 1 over 7. The least common denominator is 14, so I'll multiply the second fraction by 2 over 2. And that gives me 1 over 14 minus 2 over 14, which simplifies to negative 1 over 14. At this point, we have no more like terms, so we're finished. More examples so we can see how some problems might trick us by the way they are written. They're 14y cubed minus 9 plus 3a squared b squared minus 18 minus 19b squared a squared. So we start with the first term. The largest exponent we see is a y cubed. We have no other terms with a y cubed, so it just gets copied down, and the original is crossed out. Next, I see a term with an a squared b squared. Now, as you go through the problem, you may not see an a squared b squared, and that is because the second instance is written in reverse order. The order of the variables is irrelevant. We know that if we had 3 times 2, that would be the same thing as 2 times 3. So the order in which we multiply variables in real numbers really doesn't matter. So a squared b squared is the same as b squared a squared. The same variables are present. The same exponents on each variable is present. And so these are actually like terms. So as we combine these, we look at the coefficients, a positive 3, a minus 19, that becomes minus 16. And we just have to decide which way we like to write the variable. Do we want to write it as a squared b squared or b squared a squared? I typically write mine in alphabetical order. So once we have written these terms, we cross out the original terms. The only terms left that we haven't canceled out yet are negative 9 and negative 18. These are both constants, so they can be combined together. That becomes minus 27. We have no more like terms, so we're finished with this problem. Make sure you're careful as you go through to combine like terms. You're looking at the variables and the exponents, not the order.